Welcome to the next talk. I don't want to mess it up, so I'm going to look it up. The talk is about Docker environment for OwnCloud in combination with object storage by Wybrand, Lohman and Tom Wzepoel, both from SURFnet. Docker for me is a great tool. Object storage is is a spreading word. I think it's going to be a awesome final talk. After this talk, small organization. After this talk, there will be another quiz. And after this quiz, we got to hurry up to get the best bratwurst in the northern Bavaria, and also the best Belgian fries outside of Belgium. And after that, we'll party. So once again, warm welcome, and enjoy a nice talk.
Now, hi all. Great to see you here. We will show our awesomeness, what we have built last period. You know us from SURFdrive. That's our bigger OwnCloud instance. It has nowadays about 37,000 users and more than 226 million files and a storage quote of 331 terabyte. We deliver this to all Dutch education, higher education and research. But it is just 250 gig storage per user, and it is going through SAML for login instance. And that has some disadvantages for some more researchers who are collaborate next of out of Holland. So we decided to build something different than SURFdrive, something what's similar to it, but give us more advantages and possibilities to give researchers and sharing possibility to other researchers out of Holland. So we built LisaDrive. And LisaDrive is a bigger, same solution for research teams with larger storage quota, and gives them an option to collaborate with education and government and also private companies. We are not connected with SAML. So the idea was this. We have our users who are in the LisaDrive who can connect with commercial partners like Philips, but also with Dutch universities like UMC Utrecht, and also universities out of Holland like University of Barcelona. But we had some requirements. We want something what is branded, so we have our own LisaDrive branding, like we have the orange call for SURFdrive. It should be flexible, scalable, and we want something like a deploy environment that you can test, build, and something scalable. Now, what was our design? We want something that the user was able to add users himself directly by guest accounts or with normal accounts to give them their own quota or give them no quota, so it is unlimited. And we did that with a combination of normal accounts, LDAP accounts, and Shibboleth. So you see in picture, it's a Dutch image, but you can connect by SAML. And with the normal username and password option, you can also log in with guest accounts on normal account or with LDAP. So we combine everything what is possible. And the reason is that we have users who calculate on our compute clusters. We have a Dutch national supercomputer where researchers calculate on. And they have not a Shibboleth account because they are from outside Netherlands or they've no relation direct with us with a Shibboleth login. But they have a normal LDAP account for SURFdrive. So they can log in with the normal account, and also you have your users who are part of an institute who can log in with their normal institute account by SAML. And next of it, it has also the possibility to link external stores. So we have multiple storage systems next of the object store, which we will use for this, which can also be connected to this environment. Now, our setup, it's quite similar to SURFdrive. We have two load balancers in the top who are keeping an IP by keep alive. So one of the two is active. Then you are redirected to our Docker instance where our Docker containers on which running the OwnCloud instance with all parts. This communicate with the database cluster, and next of it, our object store environment. And this is our Docker landscape, which will explained by Wybrand.
Yes. This is a similar picture as the previous one, but it gives a slightly different view. There's basically three parts. Our friends at the network department do some magic before we reach the load balancing part, where we have HA proxy, as Tom said, and we do SSL offloading. And then the traffic gets directed to the Docker managers, who then, based on the URL, will redirect to a backend server. So we do layer 7 load balancing across the Docker containers, and that's because we don't just have resource drive, but we can also deploy branded environments. So if a university wants their own logo on it and their own URL towards it, we can manage that. We can look at the URL and redirect to the right container. And then outside of the Docker landscape, we have the databases such as MariaDB in a Galera setup. So we have replication and of course memcached for the sessions and Redis. And we keep that outside of the Docker landscape just for persistency of the data. We've built a CICD pipeline for our OwnCloud code base. So we each work in our own, just on our own laptop. We have the entire code base, and we make a checkout of the version that we want to edit, because we have a lot of patches ourselves. And we work basically on our laptop and then push it towards our Git. And in Git, we have our own fork, and we merge that into our staging branch. And what then happens is the CICD stream takes over. It will take that code, it will pull it towards the build server, and it will run some tests over that code, and then it will build an RPM, and it will make this RPM available. And then we can, on Docker, say, build me a new environment based on this RPM with my changes in it. And in our staging environment, we then have our latest patches running, completely isolated from the production. Some overview of the order of magnitude that we're talking about. Everything starts small, of course. We have 250 users. They have 8 million files. That translates into 17 million objects in the object store, and has a total of 190 terabytes of data. How we get the data is, you can see in this slide, we have sometimes up to 250 gigabytes of incoming files per hour, and a similar size of reads that go out again. It's it has some usage. This plot says something about the distribution of the data, and I can only see a ship in it that comes from the fog. It's actually very difficult to plot the distribution of file sizes, because we have many millions that are smaller than 1 MB, and we have quite a few that are bigger than, let's say, 20 gigabytes. And to put that in one graph, you need to have a logarithmic scale. So it's not easy to read this graph, but you can see it's all over the place. That's basically the message, from 1K to 40 gigabytes. To accommodate all this in a performant way, you can imagine yeah, we need to do a few tweaks left and right to get some performance. For example, because we have an object store on the back end, what happens is if most of our users use rclone. rclone uploads the file to OwnCloud. That OwnCloud puts it in the temp space, and it will then start reading a bit of the data and putting it into the object store. Reading a little bit of the data and putting it in the object store. Normally, the default is that it reads 5 megabytes, and it puts it in the object store. And every time we started experimenting a little bit with those chunk sizes, and we increased it, and we saw that we got a massive performance increasement by using bigger chunk sizes. The downside is, of course, RAM usage of the Apache workers will go up very much. So you have to cut off at some point, otherwise you consume all the RAM on your machine and it dies, and then the user is not happy. Also, a bit of a problem was, as you can see on this this picture, is that the network goes through a lot of steps. And if you have large uploads, like 20 gigabytes, and the 20 gigabytes gets uploaded, but then there's there's processing, and it's a synchronous situation. So the client has to wait until the server is done with all the processing. That takes a while. There's many places where you can get where your TCP session just gets lost, because you're sitting on your laptop, you're going through the cloud, possibly via Wi-Fi, then you get through the HA proxy, you go into the overlay network of the manager, then you go to the layer 7 load balancer, then you go to the overlay network of the workers, and then you get into the application container, and each of those will think that sessions get lost and will cut off connections and will stop serving the client. So the client thinks the client thinks the connection is lost, and it will start re-uploading the file. And PHP I/O performance, for example, is a big part in how fast it goes. So we've had to think of a couple of solutions. For example, enabling keep alive on the TCP level. That solved a lot of problems, but also on the client and on the HA proxy, we had to really up the timeout values, which also has a downside, because now it could keep ports open very long. But we're monitoring that if that's a problem. And for the future, OwnCloud has made a new object store application that we can use to talk to our S3 backend, and we've seen that really goes a lot faster than the previous one. So we're pretty excited about that. And of course, we want to integrate this further into, basically the entire surf landscape. So with HPC, the storage backend, and Python Hub, for example.
Yeah, that's it.
Yeah, that's it. Okay. Thank you very much for listening. Are there any questions? Yeah, that's a little bit of a thing in PHP. A file gets uploaded, but it reaches Apache. Apache makes it into a temp file. Then PHP makes it into a PHP temp file. So you now have 2. So every gigabyte that you upload is now 2 gigabytes. It wants to put that into the object store, but it also, the current version of the object store app, also wants to put a version file into the object store app. Now we have 3 gigabytes. So every upload triples in size, and if somewhere along these lines something breaks, and the client thinks, I'm not really sure, I'm going to try again. Every gigabyte is now 6 gigabytes. And I don't know how big of dump space you guys have, but if you have customers uploading 200 gigabytes per hour, that'll run out sooner rather than later. That's also a thing. If somewhere in this line breaks, the Apache worker that was handling all this processing will continue. It just does not care that the client and him don't have network connection anymore, because it will only use that connection when it's done. So it'll still upload the file, but there's a second process doing the same thing, and they're now locking the same file. So they will both fail, and then the third process will start, and you now have 9 gigabytes for every gigabyte that was uploaded. Any more questions? Or does that answer your question? Okay. No more questions? Thanks. Okay, thank you very much.